Artificial intelligence can write a news article in seconds, but can it give you the whole truth? In a world of deepfakes and misinformation, being well-informed has never been more critical. That's where Ground News comes in. It cuts through the online chaos, bringing you politically diverse perspectives on today's most important topics and showing you how different media outlets may be biased in their reporting. Their blind spot feed shows you stories that are receiving significant coverage from news sources you may not regularly read, so you don't get stuck in an echo chamber of your own making. Most importantly, Ground News envisions a world where civil debate trumps shouting matches, where media is held accountable, and critical thinking is the rule, not the exception. Sound too good to be true? Go see for yourself at ground.news and use my link in the show notes for 15% off any subscription. You'll be supporting this show and ensuring you don't fall victim to artificially generated misinformation. And now, on to the episode. I'm your host, Michael Callahan. This is Where We Go Next. And this week, we're discussing one of the most transformative technologies of our time, artificial intelligence. AI is already all around us, in our phones, our cars, even our refrigerators. But for many of us, this technology remains a kind of black box. How does AI actually work? What makes it think? And as it becomes increasingly integrated into our day-to-day lives, what challenges and opportunities are in store for us? To help us unpack these questions, we're joined by Harper Carroll, an AI and machine learning software engineer and educator known for making complex AI concepts accessible to a wide audience. Her online educational content has gained her a following of over 300,000 subscribers on Instagram and YouTube. Harper, thanks so much for joining us.
Thank you, Michael. Happy to be here.
Well, I'm glad that it's a pleasure all around. I've been passionate about artificial intelligence for years now. I've always been interested in technology and how it can improve our lives. While there's always the potential for downsides to any new tech, like temporary job loss and societal disruption, which we can definitely get into later, there's always, in my view, way more good things that can come out of great technology than bad ones. The juice is worth the squeeze, as they say. But the concerns that people have around technology, and in this instance, AI, are legitimate. We talked about this in the email I originally sent you to invite you onto this podcast. My wife writes for TV, and she's in the WGA, the Writers Guild of America. And last year, they were on strike for about 5 months to negotiate better contract terms. And a big thing they fought for was protecting themselves from basically being replaced by AI. And I know a lot of good people who work at the studios, but I know as a whole, if the studios could replace writers with AI, they probably would to save money. And these writers, they didn't want AI eventually doing their job. And while it can't quite do that yet, I don't think that future is that far off with the progress we're seeing. But one thing I love about your videos, Harper, is that you not only have an amazing ability to take incredibly complex concepts and break them down so that lay people like me can understand them, you approach these topics with a sense of optimism that I feel is necessary in this space, in a world that so often focuses on the doom and gloom of how AI is going to destroy the world with misinformation. So first, I just want to say thank you for what you do.
Well, thank you so much, Michael. I am really happy to hear that you take this perspective on AI and that you are feeling optimistic about it, because I am very optimistic about it. And as you said, many corporations would gladly replace people with AI. I think that's something that we need to think about and also still remain hopeful about in the case that there are other jobs. But we'll get into that. So thank you for having me, and happy to hear you take this stance.
You have an undergraduate and graduate degree from Stanford in computer science and artificial intelligence. You worked in AI at Meta, the parent company for Facebook, Instagram, and WhatsApp, for 4 years. And you've done more AI-related work at a startup, obviously including the work that you're doing on Instagram and YouTube to educate people about AI. So out of all the technologies that you could have pursued, I mean, Silicon Valley is rife with them. Why did you choose AI specifically? What first got you interested in the field of artificial intelligence?
When I went to Stanford, I had never done computer science. Actually, I delved a little bit when I was a kid to make a website. I used HTML, but then stopped using it. I got in trouble for having a website. It was harpercarroll.com. And that was the early days of the internet. And the school was worried about me being online. So they made me take down my website. But I stopped doing it. And I went to Stanford, started coding and really enjoyed it. I went to Stanford mainly for math. My two things going into college were math and acting. I loved math. I was really good at it. I also loved to act since I was a little kid. I think it's just a really beautiful form of empathy. So I went there and I thought that I would do some kind of business math situation because I'm from New York City and that's what people do. If they can do math, they just go into business anyway. And a bunch of people in my hall were doing computer science. And I decided to try it because I've always loved computers as well. Even when I wasn't coding, I always was playing on computers. And I just loved it, particularly the second course. The first course was very challenging. It was a Java course. We were making games. It was challenging because learning coding is very challenging at the beginning. And then the second course was also challenging because it taught you how to think algorithmically. It was called Algorithms. It was in C++, but I loved it. It kind of rewired my brain in a way that was algorithmic. And it was really fun to think of these optimal algorithms for doing different processes. And so when I had to choose a specialty, I considered different ones. They had human-computer interaction, which is kind of like, the graphic design of computer science. And one of them was artificial intelligence. And that one was heavily based in math. And I love math, calculus, multivariable calculus, with an extension of that, which is the foundational types of math in artificial intelligence, as is linear algebra. I decided to try it and I loved it. I thought AI is really cool. As pretty much anyone who tries it will see, it's a pretty fascinating area. And so, yeah, I kind of stuck with it. And
here you are.
And here I am. Exactly.
And I do want to say for our audience, if anyone's curious, she did keep the URL, harpercarroll.com. So she still has it. They took down her website, but they did not take her URL away, which is important.
I repurposed it today. It's no longer Tamagotchi tips and tricks. It's maybe someday I'll add that back.
In the mid-90s, I watched the original Star Wars trilogy for the first time. I was homesick for a day and I asked my mom, I was like, I've been hearing about, through my cough and sneezing, I was like, I've heard about this movie called Star Wars. Can you go to Blockbuster and rent it for me? And I became so obsessed that in 1995, I taught myself HTML and I made a Star Wars fan site where I could write my Star Wars fan fiction.
Wow. That's so cool.
That website lasted a couple of years. You've turned this into an entire career. But I totally understand how a passion can manifest itself in wanting to create a website.
Oh, for sure. I love that you had your website for the fan fiction. That's so rad. I was a big fan of writing back then as well, fiction stories. So very cool. I love to hear that about you. How long did you have the site?
Oh, gosh. Must have been like a couple years, probably from like 95 to 97. This is 100% going to date me, but that was back in the eras where you had the under construction GIFs, like the little working man has a little chisel. And then at the bottom, it had like a counter that kept track of every single visit you had. Every time I'd refresh the page and I'd see that someone new had visited, I'd be like, oh my gosh, someone read my work. Someone's reading my Star Wars fiction. Yeah. They don't really do those counters anymore. Those were cool. They don't. Maybe it's for the best. Sometimes ignorance is bliss. But circling back to AI, you have a 10 days of AI basics series. It's fantastic. I highly recommend it to anyone. You have like the short and sweet version on Instagram and then the longer, like 15 to 20 minute chunks per episode on YouTube. And in your first video, you explain the difference between AI or artificial intelligence and machine learning. And someone in elementary school, going back to the 90s again, a teacher was teaching us basic geometry. And she said something that squirreled itself inside my brain. All squares are rectangles, but not all rectangles are squares. So I loved something you said in your first video. All AI is not machine learning, but all machine learning is AI. Can you expand on that for us?
Yeah. So AI is any kind of simulated intelligence. So what that means is you could theoretically have a computer where you program it, you hard code it so that if it receives the input, hi, then it knows to say hello. And you could spend a lot of time saying, if you get X input, then reply Y, kind of just a bunch of if-then statements. That would kind of qualify as AI because someone might talk to it and it could be written well enough that someone talks to it and it's kind of talking to an AI. It seems to be kind of like a person talking back, but it's not. It's just a series of, it is, but it's just a series of if-then statements. Machine learning is when the machine learns from data that it receives how to behave so that it is then simulated intelligence. So it's a form of AI, but it is a type where it's learning how to behave on its own. So, for example, you pass it transcripts of chats, and those transcripts have person A and person B. Person A says hello, person B says hi, and then they have a chat. And so the machine learns, given someone saying hi, it learns there are lots of different responses. There's hello, there's what's up, there's hi, there's, howdy. And it's learning how to behave from examples. So that's machine learning. And again, it is a type of AI, but not all AI is machine learning, because AI in the example I initially gave, where you're coding a bunch of if-then statements, it's not learning from any data. It's just behaving exactly as you programmed it to behave.
On machine learning AI sounds almost to me like, are you familiar with Clever Hans?
No.
He was this German horse in the early 20th century who everyone thought could do math and tell time. But he was actually picking up on body language cues from the humans that were asking him the questions. A little nod in the chin that a human would unconsciously do, not even realizing they were doing that, when they got to the number that Hans was supposed to stop on, right? Like, how many days is September 12th from today? And then Hans would start pounding his foot on the pavement or on the cobblestone in Europe. And he would, unbeknownst to the humans, see a tiny little shift in the body language of the person standing next to him who would ask them the question. And when their body language changed, he would stop stomping his hoof. So people were thinking that he was actually doing the math. He was actually figuring these things out, when all he was doing was basically a call and response game. So I guess in the same way that we wouldn't really consider Hans in that respect truly intelligent, why do we consider non-machine learning actually artificial intelligence?
That's a good question. That's kind of just historically what they did. I think back in the day, that was how they programmed artificial intelligence. And I think these days it's kind of blended. So I think in most cases, when you hear AI, you're talking about machine learning. One of the big misconceptions I think that exists today is that AI is all generative AI. But generative AI, which is like image creation models and large language models, so things like ChatGPT, those are all machine learning models. So I think broadly people think of AI as machine learning these days. But technically, I think Siri was also like a non-machine learning AI. Maybe they had some machine learning, but
we could tell.
Exactly.
Early Siri was rough. Yeah.
Oh my goodness, I know.
Building on something you just said, what are the different subsets of AI? Because I hear things like large language models, large action models, generative AI. What are the different types of AI and what are the different functions they serve? Because I think for a lot of people who might play around with AI via ChatGPT or like a DALL-E or a Midjourney or something, AI is just AI. But beneath the hood, it's actually different types of artificial intelligence. What are like the main forms of AI and how do they manifest in the different tasks we have them do?
Great question. Also, I just want to say about Siri, there always was a machine learning component, and that was the speech transcription. So that it was able to transcribe your speech to text. So that's one type of AI. And so again, AI is this machine learning from data, learning how to behave. And so to answer your question about other types of AI, we have image generation models, we have word language generation models, computer vision. So being able to see pixels and identify different objects like self-driving cars, that uses computer vision. It's able to navigate an environment based on input. It's not generating any images of the output. It's just processing computer vision input and making decisions as a result of that. There's ranking algorithms. So your Netflix ranking, that is AI. Your newsfeed, I worked on newsfeed at Meta. The order in which items appear, that's all AI. Any kind of statistics or processing data to draw conclusions, that's AI. So like predicting how likely you are to fall ill or the success of surgery or whatever, given certain inputs, that's AI. So some people like to say that AI is like glorified statistics because there's a lot of overlap. Stanford actually, I think, doesn't have a statistics minor anymore because a lot of the math is just kind of similar. So there's much more AI than just the generative image and language. And AI has existed and been around for a lot longer. So for example, I was on a vacation with my mom. We went to Paris. It was very sweet. And we were using
Google Translate?
Yeah, we used Google Translate to take a picture of a menu and then translate it. And I've been meaning to make a follow-up video to this because I got a lot of comments like, this has been around a really long time. Like, what part of it is AI? And well, actually, many parts of it. Taking a photo of an image and detecting text. That's something called OCR, optical character recognition. That's computer vision where you detect characters. So it translates French to English. So it detects the characters in the image. It says where they are, and then it overlays a English translation. It translates it. And so those are just two types of AI that are in the image, and then there's another one. If you want to have it speak, then there's a model that says, okay, given text, create audio. So if I have a text that says the cat in the hat, I have a model that then knows how to translate that text into an audio of someone saying the cat in the hat. So it's lots of different models coming together in that Google Translate. And many people have been using this AI for a while, but they don't really think of it as AI.
Right. It's kind of an invisible AI.
Or it's just, it hasn't been taught to them as AI. I think the name artificial intelligence, there's been a bit of a debate in the AI community of like, why did we even choose this name, right? It was just a choice at one point that kind of stuck. But I think people don't really think of ranking algorithms or translating text or computer vision as artificial intelligence as much as they think of a computer talking to them, as in the case of ChatGPT, is that really seems like intelligence. That really seems like it's another robot. And I think people have been conditioned via movies like iRobot and things like that to think that AI is going to be like this robot-like personality that is like another human. But really, AI has existed for a long time, and it's not even close to that.
Well, it does seem in that respect that AI has a bit of a marketing problem, right? Because the term is encompassing so many different things. Is it fair to lump in one kind of AI that is taking a text and translating it? An impressive feat for sure. And lumping it in with a different type of AI that can basically have a full conversation with you, a la ChatGPT, that is learning as it's having a conversation, that is responding in a very human-like way, that is getting pretty close to passing the Turing test. There's a difference between a sandwich and a hot dog. I understand that it's meat between bread, but there is a fundamental difference there. And I wonder if it's better for us to start slicing more thinly in how we name these different technologies.
Yeah, I think you have a good point there. I actually saw someone recently say that they think that AI generated images and text and things like that, any kind of generative AI should just be called artificial X. Artificial images, artificial songs, artificial text.
That's interesting. Yeah.
Yeah. And so a couple things in addition to that. One, I mean, it does kind of make sense, the artificial intelligence thing, right? Like being able to, as a car, navigate an environment via vision. That's kind of like artificial intelligence, right? And then being able to translate a text. Humans could do that before. Now machines can, right? And so it kind of is intelligent. And then the last thing I want to say here is that the Turing test has actually already been passed in text. So when looking at outputs from a computer and from a human and not knowing if the output is from a computer or a human evaluator isn't able to tell which is human and which is computer.
Really? Which is the AI that fooled them?
I think it was like an early version of ChatGPT. I have to look at the actual history, but
really,
yeah, it's been a while since it was passed, but it has not been passed, I believe, definitely not in video.
Although I'm sure that's around the corner. We can talk about that.
Yeah, given Synthesia, the company that I just interviewed, their AI avatars are really good. Actually, I posted a video comparison of me and an AI generated version of me and asked people to guess which was AI and which was not. And 1 out of 3 people got it wrong.
For me, I thought it was about 80% of the way there. There was some syncing between what your lips were doing and what the audio was doing.
Yes.
If you focus on, this is a place that AI has had a lot of problems with, you focus on the human hands for too long and you start seeing some weird stuff. But I know what to look for, right? I think if you don't, it's getting very close. You mentioned algorithms. Are algorithms and AI like hand in hand? Can an algorithm exist without artificial intelligence? I hear those two terms thrown around a lot. So what is the difference or distinction and connection between artificial intelligence and algorithms?
Yeah, that's a great question. When I think of algorithm, it's kind of like a systematic process to achieve a given output. And so that can involve machine learning or it cannot. So you could have an algorithm that's a series of if-then statements, or you could have an algorithm that is able to find the minimum in some process, some kind of optimization problem that you have There are algorithms that you can use to find that. Some of them are more elegant in that they involve fewer if-then edge cases and instruction. Like sometimes there's just coders talk about like be really beautiful code, or maybe there's like a one-line solution that encapsulates exactly what you want to do, even if it's a complicated thing. Sometimes that does exist. Sometimes it involves more extensive coding and edge case handling, but just the process to get from A to B is an algorithm. And so, yes, that can be a machine learning problem, but not necessarily.
I recently spoke with tech reporter and author Ashley Vance. He wrote a best-selling biography on Elon Musk and recently wrote a book and produced a documentary series for Max about the private Silicon Valley funded space race. But these days, he's most passionate about and focused on artificial intelligence. And he has a really interesting perspective on how AI is progressing. Many of us, the lay people like me anyway, imagine that as AI improves, it will become more and more like us, like the human brain. But in our conversation, Ashley made the point that there's still very little we know about how the human brain actually works. It's kind of like the ocean floor in that respect. Like we've mapped a lot of it, but we're not exactly sure what's in there. And in terms of how it actually forms thoughts. And he then said this about artificial intelligence, and I've condensed the quote, but I want to get your thoughts on it. He said, quote, "I think these AIs are going to be like us, but not us. I think this is a very different form of intelligence than what is inside the brain. I'm not sure that these AIs are really going to crack the code on the mechanics of our mind. And I think that people have been talking a lot about this AI alignment, trying to align these AIs to human wants and needs and morals and safety. And I suspect that this will be very difficult to do because I think these neural networks are going to be so structurally different from the brain. I'm just not convinced we're going to have this overlap. I think we're on two different tracks," end quote. What are your thoughts on this as someone who's really deeply in this space? Will artificial intelligence and human intelligence ever converge in terms of how they work? Or will they remain two distinct forms of intelligence that think and reach conclusions in entirely distinct ways?
That's a great question. There's a lot of things that you brought up here. One of them being, we don't really know how they work. Well, that's improving. So there used to be the concept of, I guess there still is, that AI is a black box, particularly neural networks, which are the types of models that we use for things like ChatGPT, for image generation. They are a type of machine learning model that uses things called neurons, which are kind of modeled after the human brain. And these neurons learn things themselves. So you pass data through the model, and in the training phase, these neurons are learning. And over time, they learn how to basically take input and get the desired output. So if you're training a model to differentiate between a cat and a dog via images of a cat and a dog, at the beginning, it might just randomly guess. The neurons just don't know. It's just receiving a series of numbers that represent the image of a cat and dog, which is RGB values, like 3 squares of each pixel's red, green, and blue value. And it's looking at these numbers and it's saying, is it a cat or is it a dog? At first, just guessing. But over time, as it says, okay, that example you just saw, that's a cat. And that example you just saw, that's a dog. It learns to figure out patterns and features of these numbers that it's inputting. What makes those numbers a cat? What makes them a dog? And so these neurons learn features on their own. And these neurons are also just numbers. And they're numbers that, again, are iterating during the training process. And then when it's done, those neurons kind of lock into place. They have their numerical value. And then those neurons are multiplied with new input, and then they make an output. So again, ultimately, machine learning models are basically just matrix multiplications. And these neurons are setting, when you're training, you're setting the constant values for those matrix multiplications. But in the training phase, they're variables. They're changing. So these neurons are these numbers that are being learned during training. The problem with them being numbers is that when they're done training, they represent features of the model. These neurons have information about maybe this little group of neurons is able to detect whether the ear is pointy or whether it has a long, skinny, swishy tail. But we actually don't know because they're numbers. We can't interpret that. Recently, Anthropic, which is a company that's heavily focused on AI alignment, which you mentioned, which is making AI that is really compatible and supportive for humans to use. Anthropic spends a lot of money researching that. They have some really incredible AI researchers. Anthropic found that they're actually able to do some interpretation on the neurons in a model's brain, and they're able to start to crack the code on what features are these neurons detecting. So for example, the paper that they had on model interpretability is what it's called, was called Golden Gate Claude, or that was the name of the research that they were doing, because they made a model where they were able to enhance certain neurons. And when they did that, they found that any input they put into the model, any output would be about the Golden Gate Bridge. Claude is their version of ChatGPT. That's what it's called, is Claude AI.
It's pretty great.
Yeah, Claude is awesome. So what they found was that this Golden Gate Claude, when they enhanced a certain set of neurons, certain features, they would say like, hi, what should I do today? And it would say, go to the Golden Gate Bridge. Or if someone said like, how do you get to the moon from Earth? It would be like,
take the Golden Gate
Bridge. The Golden Gate Bridge. And like everything was the Golden Gate Bridge. And so there was some interest in the interpretability. And then you said something at the end. I'm trying to remember what you said, but I wanted to remark on that.
The larger question here is, you just addressed the point that we're figuring out more and more how AI does what it does, how AI reaches its conclusions. But I think the thing that Ashley's pointing to, which has me really curious, is the human brain is still very much a black box to us. So his point was, he doesn't think that the way that an AI thinks and the way that a human brain thinks will ever truly converge. He thinks they're kind of on different tracks. Do you think that they will ever converge, or will be two distinct forms of intelligence that think in different ways forever?
I struggle with this as well. I can't know if an AI is conscious. It kind of comes back to philosophy. Imagine you're someone who thinks that everything is conscious, or there's some kind of universe or God energy that runs through all atoms and molecules, and it just unites everything. But only some species are given the ability to communicate, in which case they're able to communicate their consciousness. So some people believe that dogs are conscious, or animals are. Some believe they're not. I believe they are.
But they just can't tell us.
Yes, they're not given the tools to communicate. So if you take that philosophy, and the table that I'm sitting at is conscious, but it doesn't have the tools to communicate, or maybe it doesn't experience pain or anything, but it just is. It has an isness. But if you believe that, then theoretically, AI could be conscious because it is a thing that is created by matter, and it has the kind of universe energy in it. And then if you give it the tools to communicate, it will find a way to communicate its consciousness. There are some differences in that right now existing AI is kind of just, it's like a program, but I will say it's getting more advanced. Like the fact that it even works as well as it does is kind of beyond what I can comprehend. But it is a program, right? It's a statistical kind of probability machine. But, I hear that it's getting better and better inside these companies, but it's just learning from data and it's outputting probability. And you can kind of tweak those probability parameters. So if you want it to act more erratic and say things that it's less likely to otherwise say, you can tweak a parameter on the model and have it act more erratic and out of distribution. Or you can have it just really stick to its distribution, only act on the most likely word and have it really heavily skew towards that word. So it's kind of like a machine in that sense, whereas I think we as humans are influenced by, depends on your philosophy, but mine is that there is a God, and that I don't necessarily think it's a guy up there, but I think there's some kind of divine energy, and we are influenced by that. And we're also really good at intuition. We can sense things like animals. You were talking about the horse, and I was wondering as you were saying it, like, how did they prove it was little facial expressions or gestures or body movements? I wonder if it was just a felt sense, like an energy of the person. And so we have that ability to sense those things. We do, and you can hone it and you can get better at it. So maybe down the line, machines might have some kind of quote unquote intuition, or at least be able to sense changes in our electromagnetic movements and things like that.
Separate from consciousness, are all AI companies trying to create AI in the same way? Like, let's just focus in on large language models, right? Like a ChatGPT, just for reference. Are all the companies basically trying to do their own spin on the same training? I'm going to lack the technical terms here, so pardon my layperson gibberish. But are they all trying to create the artificial mind? The thing that when I type to it and I say, hey, what's the weather going to be like today? Or, hey, I'm having this problem at work. What do you think I should do? Are they all basically teaching or training or creating the AI to respond to the problem in the same way? Or are different AI companies trying to create, let's say, for lack of a better term, different artificial brains in fundamentally different ways that will provide the same result?
Great question. So when you say AI companies, I'm just going to narrow the scope because I think only a few companies are actually building foundational models. So foundational models are models like ChatGPT, like Google Gemini, where it's kind of built from scratch. That's really hard to do. It's very expensive and takes a lot of compute. So most models are like fine-tuned versions. Most like specialized models that other companies are using are either foundational models created by Google, OpenAI, Meta, what have you, or they're fine-tuned versions of those models or open source models like Mistral. So we'll just narrow the scope to companies that are actually creating these foundational models. So building the models kind of from scratch. So when you're doing that, you get to determine the model's architecture. What that means is, like we were saying, these models are all neural networks. All these companies that are making large language models, which is what you're asking about, these chatbot models, they're using something called the transformer model, which is a type of neural network. And neural networks, again, as we talked about, they have neurons. They learn the features of the data that make it classified or do what it does, make it behave like it behaves. It learns those features on its own. And there are different choices that you can make when you are creating that architecture. So in short, to answer your question, these companies are assuming they're not talking to each other and determining the best architecture. They're building their own models within the scope of a transformer neural network. So what that means is they can choose how many layers they want. The kind of three main choices that you have when you're building a neural network are the number of layers, the number of neurons that make up the layers. So these layers are made up of neurons. So you can choose how many neurons go into those layers, how many layers there are, and the activation functions. So those are just like special functions that go kind of throughout the model that help the model capture very complex relationships between the features. And so those are the three main adjustable pieces that you can have when you're creating a neural network. And so, yes, assuming that these companies aren't talking to each other and that they're keeping their data private, which they seem to be doing aggressively in most cases, besides like Meta, which is open sourcing its models. So it's telling people how the models are built. It's not sharing the data, but it's showing the architecture, as far as I know.
Do they all trace back to the same foundational white papers?
Yeah, they're using the transformer architecture, which is a type of neural network that kind of transformed large language models. Like the transformer architecture was able to parallelize a lot of the processes of a large language model. And so it was able to allow much more complex compute processes to happen. And that enabled the models to become where they are now. Without the transformer, we wouldn't have, ChatGPT or any of the models that we have now.
Is that also, in the same way that it's empowering the AI we have today, is it also a limiting force? Like, let's say, I don't know, in some hypothetical reality, some absolute AI genius came along, like an Einstein of AI, and was like, actually, I think from the ground up, AI should be working in an entirely different way. They just say we are limited in how far AI can go because we have rooted it in the wrong thing. And so I believe that we should just completely start from scratch and build it in this way. Would they even be able to do that, or are they limited by the current hardware or current technology?
That's a fantastic question. And I do believe that there will be a new architecture to come out, like a new method of training these models. There are these researchers that are working on this. And I think I remember a few months ago seeing somewhere that there was a new research technique that was training these models without using matrix multiplications, which really blew my mind because how does that even happen, right? Like what? They're all based on matrix multiplication. So I think there are researchers doing this kind of research and hoping to find a way that takes less compute or optimizes the compute better. But it won't be me who finds out how to do it. But I believe it's possible.
Well, I'm sure you'll do a great job explaining it.
Thank you. I mean, maybe AI will figure it out, right? You said something earlier about, will AI ever think to par with us? I like to use this example. If you have a room with 5 experts on 5 different subject matters, say it's math, history, English, philosophy, science, okay? And they're experts on certain subfields within that. And then you had an AI in another room that knew exactly the same amount of information as each person in the other room, but it's just in one AI model. The AI model is going to come up with so many more, like it's not even going to be comparable, how many more parallels and insights and revelations about connecting that material than the humans in the other room. And the reason is it's all in the brain of the computer. It's able to process that information extraordinarily quickly. It's able to draw parallels because it has all of the information in its own head. And for the humans to draw those parallels, they would be talking for the rest of their lives, and they would probably maybe find one or a few. The AI brain is just so much more powerful that it can hold the knowledge of thousands, millions, billions of people in its mind, and it can make those connections that we could never make. And so as a result, for example, in science, they recently came out with a cancer treatment for glioblastoma. Glioblastoma is one of the most deadly forms of brain tumor cancer. And they were able to find cells, glioblastoma cells, so cancer cells, that could be transformed into T cells, so cells that fight tumors. Amazing. They were able to literally not only fight off the tumor cells, but transform cancer cells into cancer-fighting cells. And they were able to find remission in, I think it was 70% of cases. It was just extraordinary. So we're going to have so many extraordinary scientific breakthroughs and optimizations of different types of industries and processes like food creation and distribution, and energy distribution and optimization. And it's just amazing what we have coming for us.
On that note, I mean, anyone who's had any experience, not just with the invisible AIs, right? Like the Google Translates and all the other ways that AI affects us and works with us throughout our day to day, but even the more recognizable forms of AI, like a ChatGPT, like a DALL-E, like a Midjourney, where you ask it, hey, make me an image of a Tyrannosaurus Rex riding a tricycle. And 30 seconds later, there you go. Or, identifying cancers in the brain. It does so many amazing things. And yet we can feel like intuitively, there are many ways in which it's just not able to do what the human brain can do. Where does AI, in its many forms, still struggle? In what ways can it not achieve what the human brain can achieve? What makes humans special?
I think what makes humans special is our ability to really connect with each other. I think we have an intuition that they don't. I think we also are good at changing our objective functions. Right. So one issue that some AI doomers say, so people who think we're going to die by AI's hands, they talk about the paperclip problem, where you have a machine that's optimized to generate paperclips.
Right.
It's not going to know to not destroy all of humanity to optimize paperclip production, right? Like needs the space or it needs the resources or...
I would be much more efficient at creating paperclips if I killed everyone first.
Yeah, right. Or like there'd be a lot more space or we need the water or whatever. And so that's in a very extreme case. But I think what it's getting at is that we as humans kind of hold all these objectives, and then AI is trained for one objective. So in the case of large language models, it's trained to, given the input that it's received, output the text that is actually output in the training data. So if it receives the cat in the, it's trained to output hat with the highest probability, right? If the input text was the cat in the hat, then if that was the training data, then it's kind of just training to mimic the training data the best, frankly. But we as humans hold many, right? If we want to cross the street, we're not going to throw a baby out of the way to get there. And I'm not saying that AI is going to do that. And as it's getting smarter, I don't know if this argument is going to hold up forever. I think AIs are getting better at holding many different goals at the same time and acting in ways that if it crosses a street, it's not going to throw a baby out of the way, right? It's getting better at this kind of consideration.
Is what you're talking about why, when I'm talking to an LLM like a Claude or a ChatGPT, like if I'm trying to brainstorm on something or just really try and get out of my head and get quote unquote someone else's opinion on something I'm working on, sometimes I like to treat these LLMs like a junior level creative partner where I'm just like, all right, I'm trying to do this XYZ, whether it's planned for a podcast episode or try to work out a commercial script. And I'm just like, okay, here's what I have. What am I missing? Or here's what I have. Can you extrapolate on XYZ? And what I'll find will happen is sometimes it will understand exactly what I'm asking for, but I have to do oftentimes so much hand-holding. Like, remember that I just said this, and keep in mind that I said this, and please do this, but don't do this. And it's just a lot of extra verbalizing what I do and don't want it to do that a human being would be able to contextualize and intuit automatically. And is that kind of what you're getting at? Like, those are the kind of differences that eventually AI will get better at closing?
Yeah, I think AI will get better at closing that. And also, I'll just say two things. And this was something you also mentioned earlier, are these companies building different models to kind of do the same thing? There's something called the system prompt, which is a prompt that the company passes into the model before the model talks to you. So again, this company Anthropic that works on AI alignment, they recently published their system prompts and they're calling all other companies to publish their system prompts. But it tells the model to be curious and thoughtful and kind of gives it a personality. And it's this extensive prompt before whatever prompt you give it. And so these models kind of have different personalities as a result. But then, yeah, I think models will get better at holding that contextual or world understanding of how to behave. I think they'll get better at that. But also, sometimes you want to untrain that in humans, right? Like it might be able to limit how we behave when we come to the table with all of these preconceived rules and notions about what you want when maybe that isn't what you want.
Right. Our brains are software, right? And we're influenced by all kinds of things that happen in our life, like childhood trauma or the morals or values we were taught or not taught by the adults around us when we were kids, or just our own personal biases. And that's kind of the system prompt in our brains, I guess.
Yeah, right. Exactly. I agree.
Every time someone cuts me off in traffic, I'm going to curse. System prompt.
Yeah, I mean, you could. Oh my goodness.
But if you retrained it, you'd be like, someone cuts me off, I'm just going to take a moment to meditate in my car and I'm going to let it go past me.
Yeah, you could change the prompt. You wouldn't even have to like retrain the model. You could just change the system prompt.
Are you familiar with the work that Mackenzie Mathis is doing out of Switzerland?
No, please share.
So she's an American neuroscientist. She's leading a lab within the Brain Mind Institute at the Swiss Federal Institute of Technology. And one thing they're doing, which is really quite fascinating, is they're teaching mice to play custom made for mice video games with treadmills and little joysticks. And they record the mice's neural activity as they learn and adapt to the game. And the researchers' aim is to use that knowledge, that data, to create new AI algorithms that are based on how real brains work. So like looping back to what we were talking about earlier, they're literally hooking up these mouse brains to a computer that can see all the neural activity. They can then use that data to be like, okay, when that mouse is turning left in this maze and pulling the joystick, the neural connections in that mouse's brain are lighting up in this way. And we can hopefully use that data to then train an AI algorithm to replicate that process. So we can literally, hopefully train AI to think in the same way as an animal, and I guess eventually humans' brain.
This reminds me of research. Two things this reminds me of. One is research where the machine learning person is modeling the brains of people who are locked in. So people who can't talk or move their mouths or anything, or really move their bodies at all.
Like the diving bell and the butterfly, if you've seen that.
No.
It's an example of someone who suffered from locked-in syndrome, and the only way they could communicate was through blinking.
Okay, yeah, exactly. And so what these researchers are able to do is take the brain scans of these people, they show them different images, and they're able to see like, okay, when they're looking at a truck, what parts of their brain light up, and when they're looking at a dog. And so they're able to then codify, encode, and then decode the brains. They have a training phase where they learn given inputs and then the associated brain activity. That's the process. And then they're able to then do brain activity to what do we assume the input is. So if they have brain activity, what do we think they're thinking about? If they're thinking about a dog, you would assume that the same brain activity lights up as when they're looking at a dog.
Every time they think dog, this happens.
Right, exactly. And so then they're able to translate for those. They're able to allow those people to communicate. And they also had cases where they were able to look at videos of their voice and have it translate that text into spoken audio. So the person can actually speak in their voice by thinking. And so, yes, this kind of brain scanning and modeling has been happening for a little while now. They also, I think it was like Harvard research that was able to fully model a mouse's brain as it's moving through an agility track. And then the second thing this reminded me of was they're actually starting to do research on brain organelles, so like brain cells, as faster computational resources than machines. So this is a little crazy, but there's some research, I think it's in Switzerland, and I think there was another company I just heard about too that's doing this, where they're taking brain cells and doing calculations using the brain cells instead of like on a chip, a machine chip, kind of like NVIDIA. And they're able to be like 1,000 times more powerful or something crazy, maybe even more than that.
A lot of interesting stuff going on in Switzerland.
So yeah, kind of crazy. We actually might use brain cells to do this kind of processing. That adds a whole new level to this kind of AI thing, right? Because they might actually have brains, which is crazy.
You mentioned the AI doomers a little earlier. Let's give them their due. In my personal opinion, I think a lot of the fears are overblown. But again, circling back to the WGA's contract fight last year, I think there are real legitimate fears when it comes to things like the spread of misinformation or job replacement. There are times where I'm playing around with Midjourney and I'm having it create a prompt, or like I look at something that came out of Runway, which is similar to an image generator, but in this case, it's generating pretty damn good video. And granted, it's in the infant stages now, but I could see a world 5-10 years from now where I'm potentially out of a job, right? So what do we say to those people who see something like AI? And even if they are maybe excited for all the good things it could do for them, they see what they consider to be potential downsides, either the spread of disinformation, a fake video of President Obama telling you to kill your neighbor, like whatever it could be. What fears of theirs are legitimate in your view? And what's being done on the ground, either at the governmental level, the nonprofit level, the regulatory level, where we can address these fears without hampering the progress of technology itself?
I think there's some fears that are founded, like the extreme case where we die from AI. Like, okay, if everything exists on a probability distribution, I would say the likelihood of that event is extremely small. Maybe as we go further and further into the future, it becomes more and more likely, but I'm not really too concerned about that. But okay, misinformation and disinformation. I think disinformation is intentional, false information, and misinformation is, if you're discerning between the two, is not intentional. But that's been going on for as long as people have been able to talk. They've been spreading falsities. I think the media regularly spreads false, or rather extremely misleading information. They take facts and put it together in a way that is portraying a picture that is completely false, taking facts and stripping them of all their context, and then organizing them in a way such that the story that someone is telling themselves in their mind when reading it is actually not the truth at all. Technically, they're not lying, but they know that they're being deceitful. That's been happening for a long time. I think AI, in fact, might make people more aware of this. I think one of the issues with the media is that people have approached the media blindly believing that what they say is true, even though they're trying to sell clicks, they're trying to sell eyes, they have children to feed. It's an attention economy. And so a lot of these writers who are writing news stories that are supposed to be factual are intentionally misleading people to get the eyes that they need.
There's this app called Descript, which I use to make audiograms for this podcast. I use it to do sound editing. You can put either audio or video into it, and then it transcribes all of the audio. Speaking of AI, transcribes all of the audio into a literal transcript, which you can then edit like a Microsoft Word document. And the edits you're making to the transcript happen also in the audio. So instead of having to have a timeline where you have an audio wave, like we've been doing for the last 20 some odd years, and you have to make those independent cuts as you listen to the audio, I could go Control F and just search for, remember when I was talking with Harper and I said the word tortilla and just type in tortilla, and I'm like, all right, let's just cut that whole section out. I edit the document, it's gone from the audio file. But it has this technology where I can train it to sound like me. Let's say, for instance, I got some information wrong in this conversation, or I said tortilla instead of hot dog. Now, back in the day, I'd have to go back in and re-record my voice. So I'd say hot dog instead of tortilla and hope that I match how I was talking when I was talking with you. But the script, because I can train it to sound like me, I can literally go in, type hot dog, and then now it'll generate my voice in the middle of a sentence, right? And I will say to my listeners, you have heard examples like that in many of my episodes without ever realizing it. But we're pretty close to a future, Harper, where, I don't know, 6 months from now, who knows how fast that can happen, where you could listen to a bunch of my podcasts, train an AI to sound exactly like me, and have me say things that could get me fired from my job, right? So to try and make it a little more tangible, there are new kinds of disinformation that are only possible with something like AI today, right?
Yeah, no, absolutely. And I don't mean to downplay that, but I guess what I'm trying to say is, I think it's good that we're getting more awareness on it. I'm not saying there aren't going to be issues. 100% there are going to be issues with this, as you know, there are with most advancements, right? And so everything has pros and cons. And so, yes, we're going to have to consider that there are deep fakes and there are generated audio that might not be real. But I think as people become more literate in the sense that they're more aware that there are fake things online and images could be fake and audio could be fake, it's actually probably a good thing because
our antenna will be up?
Yeah, right. That's what I'm trying to say.
I want to touch briefly on NVIDIA with you. I work in video game advertising. So NVIDIA, which is a company that has long specialized in making powerful GPUs or graphics processing units, is a company I've been familiar with for a while. As of this month, NVIDIA has a $3.25 trillion market cap. Why? And how is this related to something called CUDA?
NVIDIA makes the machines that allow AI models to train and run. So as I said, AI models are a series of matrix multiplications right now, or machine learning models in particular, are matrix multiplications. And what graphical processing units are they are machines that were initially made to, as you said, play video games. They process graphics. And what graphics are matrices. They are, as I said, computer vision. It has RGB values, and it's processing those matrices. Matrices are like squares of data, or rectangles, of data. And so they are being repurposed to train AI models. And CUDA is a software that was made by NVIDIA that allows people who are working with AI models to easily load and work with those matrices on these machines. Typically, training and working with these machine learning models, which are made of these matrices, is challenging. But what CUDA does is it makes it really easy. It parallelizes the processes, so it distributes the data, the matrices, across machines. It does the calculations for you. It optimizes the performance of training and running. And so that has given NVIDIA an edge over other GPU companies like AMD, for example, where it's still kind of a pain in the butt to train and work with the machines because they don't have this CUDA software that makes it easy.
So on the topic of NVIDIA, let's talk power consumption. Paul Chernock, the former senior principal electrical engineer of data center technical governance and strategy, really rolls off the tongue, at Microsoft, and now the VP of engineering at a data center startup here in LA, wrote in a LinkedIn post in 2023 that NVIDIA's H100 GPU, designed specifically for AI applications, quote, has a peak power consumption of 700 watts. At a 61% annual utilization, it is equivalent to the power consumption of the average American household occupant. NVIDIA's estimated sales of H100 GPUs is between 1.5 and 2 million H100 GPUs in 2024. Comparing to residential power consumption by city, NVIDIA's H100 chips would rank as the fifth largest, just behind Houston, Texas, and head of Phoenix, Arizona, end quote. Getting us to our AI-powered future is an incredibly energy-hungry enterprise. So I wanted to talk about the series of videos that you've been doing with Isabel Bemeke, who promotes the benefits of nuclear energy while dispelling the many myths surrounding it. You're doing a series of videos with her. So I'd love for you to just explain why you are.
Yeah, that's a great question. So Isabel is an influencer in nuclear electricity, and she's been working on that for a little while now. And I honestly, not too long ago, was really taught about the energy impact of AI. It wasn't really something that, they didn't talk to us about it when I was getting my degrees, and I didn't really have to think about it much when I was working at various companies. And then I learned, wow, it actually takes a lot of energy. And I was surprised that it was relatively new to me. And so I was like, okay, I have to learn about this. I have to teach people about this. This is really serious. And so I reached out to Isabel and I talked to her about it. And she was saying that nuclear is actually really uniquely positioned for AI. And so we got to talking, and then we realized, oh my gosh, we should do a series together on this. And she's been thinking about this a lot. She's writing a book. She's been helping to educate people on why nuclear is useful. And then as a group effort, we've been just, researching some of these crazy stats, like how a Google search with AI takes 10 times the energy as a typical Google search.
Wow.
Right? Like Google had this AI enhanced feature on their search for a little while, and it took 10x for a single search for as many searches as there are, it's 10 times. So that's pretty amazing and concerning. And that's just for one company. And so if you go look at the videos, the first few talks about these stats. And actually, Jensen Huang, the CEO of NVIDIA came out recently and said that we need to have nuclear or else AI is just not going to progress. Like there's just no way to supply the demand for AI without nuclear. So it's a really important topic.
You make a really good point that this problem can't be solved with something like solar or wind because the energy is not consistent enough.
Yes.
AI is not going to take a break when it's not windy outside or when it's a cloudy day. But if we don't build something like nuclear power to feed the energy needs of AI, we're going to have to turn to much dirtier sources, which is going to have second and third order effects that no one's going to like.
Yes, exactly. Yep. They're not consistent like solar. If something is in front of the sun, like a cloud or, at night, obviously, when the sun goes down, like it's not consistent. We need the consistency.
I could 100% talk about this topic with you for another 3 hours, but your time is limited and valuable. So I want to ask one more question before I let you go. I looked through the comments on your Instagram videos, and I wanted to share a few with our audience. Quote, "The approachable presentation you have is the best for this field I've yet to see online," end quote. Quote, "You have a great ability to teach complex topics in simple terms," end quote. Quote, "This is super informative and clear. Looking forward to more posts on how to use AI and ML tools," end quote. And that last comment is from Andrew Huberman. So what is the secret to teaching about complex topics in ways that most people can understand? How does your brain break down a problem so you can translate it for people without your background? Or to put it another way, more relevant to this conversation, Harper, if we were to examine your thinking like the code of a large language model, the system prompt, if you will, what would we find?
Well, first of all, thank you for the sweet comments that you read off. That made my day.
AI is really complex, hard to understand. Like I am probably going to go back and listen to this conversation and be a little embarrassed with the terms that I missed or got wrong, et cetera. And the way that you were able to break this stuff down, like I highly recommend anyone go check out Harper's Instagram or her YouTube videos. They are masterclasses in taking highly complex information and explaining it in a way that doesn't make the viewer feel like an idiot. That's really hard to do. Like sometimes I'll catch myself trying to explain filmmaking to someone who has no background, and they will stop me like, wait, what does that mean? What does that mean? Actually laying something out that doesn't alienate the viewer is a very specific skill set. How do you work through that information and break it down in a way that doesn't alienate people who don't have a background like you do?
I have just always loved teaching. They say your skill is what you think is easy, but other people don't. And so I'm just kind of like explaining it in the way that feels right to me. And for some reason, it works really well. And I don't know why, but I've always loved teaching. I've always loved helping people understand things that I think are really cool. Like ever since I was a little kid, I would come home after learning a science experiment and come teach my little sister, or I would teach her math or whatever. I wanted to help her understand it. So maybe I'm just repeating the process, like how I got there, like how my brain got there from start to finish. I just know that I love to do it and I love to help people understand things because I think everyone can understand anything. It's just a process of like A to B or A to D. But I'm just really glad that it works and I love to do it. I just feel so lucky to be able to do it as like my job now. It's the best.
To wrap us out, there was something cool I learned while preparing for this conversation, Harper. It's that Mount Sinai in New York City has an in-house broadcast studio called KidZone TV that, quote, produces 4 live shows a day, 7 days a week for pediatric patients and families, end quote. And that KidZone broadcasts throughout the Children's Hospital on a dedicated channel. And that is really cool. And back in high school, you hosted and assistant produced 2 live educational game shows every week for KidZone TV for years. And you also acted in an episode of a CBS crime drama in your junior year of high school. So it's clear that you've long had a passion for both education and performance, and you're combining them now with your educational YouTube and social media videos. And I'm glad that we have you out there making such deeply informative content, like how to use AI, how to code with AI, what's new in AI, how AI is going to change our lives, that make the rest of us more informed and, importantly, less afraid. So thank you so much for the work you're doing, Harper. And today, most of all, thanks for your time.
Thank you so much, Michael. Thank you.